and welcome to 2015 Tsinghua Management Global Forum. Each year, in connection with our advisory board meeting, which will take place tomorrow, we organize this global forum. And each year we feature one board member. Last year was Tim Cook of Apple, and this year we are very, very honored to have Elon Musk to join us tonight. I feel very honored and humbled to be with you tonight. By the way, all of the audience here, except some people from the media, all the students from Tsinghua, most of them not from the School of Economics and Management. They are from Science, Engineering, from Tsinghua X Lab, Tsinghua Accelerator, all these places. So most of them are Science, Engineering majors. They are the lucky ones because we have very limited seats available. So they are very, very lucky to have to secure seats here. They are all your admirer. You can see that the students are very enthusiastic, very keen to listen to your insights and stories, and with them to share your insights with them tonight. We also broadcast this through CCTV in this building. There are some other classrooms, so for those people who could not get into this auditorium. Now, since we are in a university, most audience students, I would like to start my question from your college experiences. So I know that you moved from your home country, South Africa, to Canada to attend Queen's University for 2 years, and then you transferred to University of Pennsylvania. And in both places, you started as a business major, but then you added another major of physics. So I think all these students are interested to know that what the most important things you learned from college, in economics, in business, and in physics. How this college learning experience affect your later career. So tell us about your college experience.
Sure. Well, it wasn't really super well thought out, actually. Is it on? Right.
Okay.
So it wasn't really, my college education wasn't really super well planned out. It was, in fact, I wasn't sure whether I wanted to go to college at all in the beginning.
You were not really thinking about going to college at the beginning.
Yeah, I wasn't sure whether I should go or not. So I think I originally moved to Canada when I was 17.
Not for college. Not for college.
Interesting music. No, originally I wanted to get from South Africa to North America because it seemed like a lot of the cutting edge technology was really so I moved when I was 17 by myself without my parents, and without really an explicit plan of going to college. Just that I wanted to be here where the technology would be created.
That's what your intuition is.
Yeah, well, every time I read about some new technologies, it's because of,
North America.
Yeah, pretty much.
It has to be North America.
Yeah. I like technology. So as soon as I got my Canadian passport when I was 17, I went to Canada against my parents' wishes. Actually, they tried to convince me to stay.
Ran away from home, basically.
I wanted to go where the technology was, and I couldn't convince my parents to move, so then I had to move myself.
Okay. Before age 18. Did that.
Obviously before the internet or anything. And so I wrote letters. I had some distant family in Canada. I wrote letters to them, but I didn't get any letters back, so I just went anyway.
Did you find them?
Yeah. Sure.
Did you finance?
Well, I had like a great uncle in Montreal, and when I arrived in Montreal, my mom finally got the letter back that said he was in Minnesota for the summer. So then I was just like, so I just stayed at like a student hostel and bought a bus ticket across Canada. Anyway, and so then I worked for several months in various computer-related roles, mostly in Toronto, and then I decided that I wanted to go to college because otherwise I would have a difficult time meeting girls. So, because everybody was like much older than I was at the companies that I was working at, so it seemed like that I would be missing out on an important social experience. So that was really the deciding factor.
Why did you choose business major?
Well, I actually was considering two possibilities. One was to study computer engineering at the University of Waterloo, and the other one was to go to Queens. And I went to Waterloo, and I saw there were not many girls there.
Not many girls?
Yeah. So this seems like, okay, that might not be so much fun.
Queens.
Then, yeah, so then I went to Queens, which I did meet my wife there, so that worked out.
Okay.
Yeah. And I did a broad range of subjects, so commerce and engineering and math, and so it was kind of a broad range of subjects. And then somebody that had been at Queens went to, they transferred to UPenn Wharton, and they gave it a very good report. And so I thought, well, I'll apply to go there. But I didn't have any money, so in order to go there, I needed to get a scholarship. So I thought I would not get a scholarship, but I applied anyway, and they did give me a scholarship. So,
wow, what can you do scholarship?
Yeah, UPenn Wharton.
Yeah.
Yeah, so then I had to go because of that. And yeah, so then I was there. I finished like business courses in a year, and then but you have a minimum of 2 years.
I see.
So then I thought, well, I like physics, so I'll just study physics for the second year. And then I thought, well, I could either go to Wall Street or go more into the science and engineering thing, and I decided I'd rather do science and engineering. So I stayed an extra year and finished with a physics degree, and then went to Stanford with the idea of working on advanced capacitors for use in electric vehicles. And there was some fundamental physics involved, so it was kind of a combined physics and material science sort of program. But then I dropped out and started a company. 2 or 3 days. Well, I went on deferment, technically.
Okay.
Yeah.
They
said I can go back.
You still can go back.
Yeah, they said I can come back for no tuition.
So you said we started in business and then studied physics. You found physics more interesting or harder than business and economics, or?
Yeah, my interest in physics and just in general in science was more from the standpoint of trying to understand the nature of reality. You know, what's it all about? What's the meaning of life? What questions should we ask about the nature of the universe? You know, that was really my main motivation. Actually, the only reason I studied business at all was I was worried that if I graduated and then I'd have to work for someone who had a business degree, and which wouldn't be that bad. But then if they knew special things that I didn't know, then I would have a disadvantage.
So basically, you just want to learn business. You want to develop some common language with your future bosses. That's the motivation.
Yeah, just like, I was mostly afraid of having a boss that I didn't like.
And then you become your own boss,
yeah.
So you can avoid that problem.
Right, exactly.
So you mentioned in many occasions that physics, about physics, you like physics. You talk about first principles of physics that help you think complicated things and use. Alright, so tell us give us some examples why the principles of physics is so important to shape your life or your way of thinking here?
Yeah, well, I think physics is essentially, I think, developed the best framework for understanding new things that are counterintuitive.
Counterintuitive.
Counterintuitive, yeah. So you take something like, say, quantum mechanics, which it's very counterintuitive. It doesn't seem as though reality should work that way, but it does, and it's experimentally verified to extremely high precision. And so the way that physics is able to make progress in this, in these counterintuitive fields, is by boiling things down to the most fundamental truths and reasoning up from there. I think this is a very important approach to, really the only approach that can work when you're trying to get into something new, where it's unexplored territory. Because normally the way we get through life is we think by analogy. So we essentially do something. We basically do what everybody else is doing with minor variations. And that provides a mental shortcut. So the amount of thinking that's required to do that is not much. And that's fine for everyday life. We can't think all the time about those principles because it's just too computer intensive. But in trying to understand new things, this is extremely important.
You are making a point that if you really want to be original or creative, you have to think in terms of first principles. Everything go back to the fundamentals.
Yeah.
That will be creative or original. Otherwise, we're doing minor variations using analogy. Basically.
Well, you don't know what's really true or what's really possible if you reason by analogy. Analogies are very seductive. They can sound very compelling, but an analogy is really just a story.
It's just a story.
It's just a story. And they said they can be very appealing, seductive stories, but it's really just a story.
I think that's very, very inspiring comments because here we accustomed to analogy things because that is a shortcut basically.
It's a shortcut.
It's a shortcut. So
you need to do that most of the time.
Most of the time we do that.
Yeah, otherwise you couldn't get to it.
Okay, in order to survive, you do that.
Yes.
But in order to be creative and original, you have to go back to the first principles. Right? So that's the key to the thing. I think this is something. We have a professor of physics here, so Professor Zhu, you can you have a microphone there? Yes, please. Quantum mechanics. So that's out of my field.
I'm very pleased to hear you like physics. For the principle.
First principle.
I want to know what's your opinion about the science education in high school. In China, it is well known that physics and science is important for the technology innovation. But the physics is a very tough course for students. Nowadays, China education experts think the American students study very easy and enjoy life. But Chinese students have a very heavy workload.
Sure.
So Chinese education administrators want to reduce the working load of Chinese high school students. What's your opinion?
To reduce the physics courses in high school.
Well, I think it would be relatively pro-physics.
You are pro-physics.
Pro-physics, but I think the biggest issue is that physics is usually not taught in the right way. The way physics is usually taught is as a series of rote formulas. Remember this formula, this formula, and this formula, and the fundamental meaning is not conveyed. What do these things? What do these formulas represent in reality? It's incredible that there can be a formula that actually describes reality. That's amazing. And the wonder and awe of physics is not conveyed in classrooms. And it's very important also to teach to the problem and not to the tools. You can imagine, like, if you say, we want to understand how an internal combustion engine works, then the best way to do that is to say, okay, now let's take it apart and look at the pieces and then put it back together again. And then what tools would we need for this? Okay, we need a screwdriver, we need a wrench, we need maybe a winch, and these various tools. And then as you take the engine apart and put it back together, you understand the reason for these tools. But if, on the other hand, you had a course on screwdrivers, a course on wrenches, that would be a terrible way to do it. And it's difficult to remember. And the way that our mind has evolved is to remember things that are relevant. And so unless you establish relevancy, it is very painful and difficult to remember things because they seem abstract and important. So you have to establish the relevancy and importance and establish the why of things in order for the knowledge to naturally stay in your brain.
So physics is important, but should be taught differently.
Yeah.
Not just remember all the formulas, but have to have the problems. What's the fundamental problems?
Yeah.
So I think that's the very, very interesting thing.
You want people to feel the amazement and awe and like it feel incredible and feel like a story. Not just a bunch of formulas that seem meaningless.
Very good. So that's something that here at Tsinghua is very relevant to our teaching of physics here. So. Now I want to move to what are you doing now? Now I brought this is a table, MIT Technology Review, 50 smartest companies, 2015. There are 50 smartest companies in the world. Now, Tesla Motors, SolarCity, and SpaceX occupy 3 places on this table. Number 1, number 9, and number 22. Isn't that amazing? I think for me or anyone here, if you have one company to be listed here, you'll be very proud of. They have all 3. And Tesla is also on the first place, so that's quite incredible. So my question is, I know that these are the 3 companies you have been working with since 2001. So before that, you created 2 other companies, Zip2 with your brother, and X.com later becomes PayPal. That's very important detail. So my question is, before we get into each of these cases, is that in the early 2000s, when you sold the other company, you started gradually these 3, in addition to the capital you gained, of course, to invest in this, what other lessons you learned from your 1990s experiences, as the founder of those ventures, for your later, the next 15 years of this, in these 3 very different industries, aerospace, automobile, and clean energy. Apparently, there seems to be there's no connection between the 2. The first 2 companies are all internet companies. So can you share with us some of your thoughts at the time and your just accident or just by chance or no?
Well, not really. I mean, when I was in university, I thought I would like to be involved in things that would have a positive effect on the future, and some of the things that would have a significant effect. And the 5 areas that I thought were that way were the internet, sustainable energy, making life multi-planetary, genetics, and AI. And the last 2 I was sort of, thought those would be kind of a double-edged sword.
AI, artificial intelligence,
yeah.
And biology. For these 2, you have not gotten.
Tangentially, I've gotten into them, and I didn't think I'd actually be involved in all of them, but it turned out, at least for the first 3 that I have been. But it was really more from the standpoint of I wanted to be involved in things I thought would have a big effect on the future, as opposed to creating a company to create a company. In fact, in the beginning, I actually tried to get a job at Netscape. So it wasn't from the standpoint of trying to start a company, But in '95, Netscape was like the only internet company really, and I sent in my resume, but I didn't get a reply.
You didn't get a reply from
No.
Netscape?
No.
So Netscape helped you a lot.
And I tried hanging out in the lobby, but I was too shy to talk to anybody. And so then I thought, okay, if I don't start a company, then I don't know what else to do.
Okay.
But it wasn't, and that's why I created my first company.
So basically, when you don't find a job or interview, that's a good opportunity for you to start your own company. That's the number one learn all the students here.
But I mean, it's mostly the optimization I was trying to. I just wanted to do useful things, to be maximally useful. That's really the main thing.
Well, I think all these people here that they want to do useful things, but think about take an example of SpaceX. Okay? This is the area traditionally we would think is exclusive of government to do it. It's very high level from technological point of view, from financial point of view, from regulation point of view. Many people, I guess, they want to get into this area, but they feel just impossible. But what made you think you could do it? And you started this in 2001, right?
2002.
2002.
But yeah, I can tell you the origin of SpaceX was really not from the standpoint of trying to create a company. In 2001, I was talking to a friend of mine, and I was just wondering why we had not gone to Mars. Because if we had gone to the moon in 1969, then surely by now we should be very close to getting to Mars.
Okay, that's your original question.
Yeah.
Why now we get into Mars?
Yes. So I thought, well, I'll go on the NASA website to find out when we're going to Mars.
Okay.
And I went on the website and I couldn't find it. And then I learned that actually that had now been taken up with the NASA goals at that time. So I thought what I would do is try to do a philanthropic mission to send a small greenhouse to the surface of Mars, because the public responds to precedents and superlatives. And this would be the furthest that life's ever traveled, the first life on Mars as far as we know, and you have this great chart of green plants on a red background. And I thought that this would perhaps get the public excited enough to increase NASA's budget so that we could kind of resume the dream of Apollo. That was actually the origin. And actually, I went to Russia 3 times to try to buy some used ICBMs to send the mission to Mars, and I did negotiate a deal, but I came to the conclusion that I was actually, my premise was incorrect. I actually thought that the reason that we had not gone to Mars was because of a lack of will, but in fact, I think the will is there, but then people must believe that there's a way. If people think that there's no chance of it being successful, then they will give up. So I decided that I had to try to start a company to reduce the cost of access to space, to improve rocket technology. Because it had been essentially in stasis since the 60s. There's no fundamental improvement that's occurred. In fact, so I can argue it's gotten worse on a cost per unit mass to orbit basis. So that was the basis for starting SpaceX. But at the beginning of SpaceX, I thought maybe there was a 10% chance of success.
10% chance?
Maybe, at most, yeah.
So you took the risk?
Yeah, I mean, it seemed like if there was not something, if something wasn't done to improve the rocket technology, then we would never get there.
So Russia did not sell the rocket to you, or you thought it's too expensive, or so you want to develop your own?
Well, they actually, I did come to terms with the Russians, but then the only reason that the rockets were lower cost was because of production talks. So they were essentially scrap rockets. So even if one could use those rockets, but once you ran out of the scrap rockets, because of armed production talks, then you'd be back up at the high prices again. Mm-hmm. So it was at most a short-term possibility. It would not result in a long-term benefit. It would certainly not result in the establishment of a self-sustaining city on Mars, which is really the goal that we should have in this case.
Okay, now we have the will. Now you did some initial work. You contacted Russians, and you thought there's no progress made in the last few decades, so there's a possibility. But then, rocket science is very hard science. So you are not only a chief executive officer, but also chief technology officer. So your college degree is from business and physics. You only spent 3 days in the PhD program. So my guess is that, I'm pretty sure you're self-taught. You learn all these hard science engineering, computer programming, physics, and all others by yourself, engineering. How did you do that? Tell us, a student, that you can do that without going through the formal programs, basically.
Oh, sure.
Really?
Well, and experimenting, of course. I mean, experiments in books. Sometimes the things in the books are not correct.
Okay.
Yeah, but that's basically how it works. I mean, you can learn things very quickly if you just read the books. I mean, information's all there.
You pick up a book, you learn and become an expert in this hard science engineering area, you could do that.
Yeah, I mean, at the risk of sounding like a robot, your data rate in reading books is much faster than in a lecture. You can read information far faster than you can hear it. So then it's much faster to read.
Well, I'm a little bit worried we'll be out of job now. But it's true that we teach many physics courses here, right, for physics majors. You probably have some questions here that, about what courses.
Yeah, I think genius students can self-study physics. But anyway, the physics is based on experiments. In particular, for the engineering and hard technology, it also should to do some experiments, even to do some machine in the factory. How can you get such a real experience from self-study? And I have another question about what kind of physics course do we like the most? Which physics course do you think most helpful for your company, for your creative thinking, for your so wonderful company?
Sure. Actually, the fundamentals of physics that's what's most helpful. The very framework of how to think about physics is by far the most helpful. And to sort of understand how did the first scientists learn anything, and how did they change the way that they learn things, how did they change their framework of analysis over time as they learned that one mode was better than another. This is extremely helpful to know. And so honestly, it's like Physics 101 is like if people really pay attention to Physics 101, that's the most valuable. And then I thought quantum mechanics was really interesting too. It's amazing that quantum mechanics is true. It's still hard to believe it really.
So I'm thinking that put quantum mechanics as a required course for School of Economics and Management students. So
it's a hard one, right?
it's a hard one? Which part is hard? Is mathematics part or principles part? Or which part is hard? It's counterintuitive.
It's extremely counterintuitive, so that you can't just use the way that you normally would think about the way that reality works, which you can in many other areas. So because you just don't have, your intuition is not a good guide, that makes quantum mechanics quite difficult. It also combines quite a lot of advanced math and statistics at the same time. So if you're very good at statistics, then quantum mechanics would really help. Yeah.
Okay, I need statistics.
Yeah. And statistics is quite hard too.
You like statistics?
Absolutely, yes. Statistics are very interesting. I think everyone should learn statistics too.
Everyone should know.
Yeah, very important. Otherwise you can get tricked too easily by these things. There's that famous saying, I'm not sure who it was, maybe Churchill or somebody said, there are lies, there are damn lies, and then there are statistics.
That's right. That's 3 times 5.
Yeah.
Did Churchill say this?
I think maybe I'm not certain.
Huh? Israeli said.
Israeli.
Okay.
Yeah.
Yeah, I know.
There's some roach there.
Very good. So now, so we have so it's been 13 years since you started SpaceX. I know your aspiration is to send humans to Mars, and with reusable rockets, reduce the cost by a factor of 10.
I think ultimately a factor of 100.
Ultimately, a factor of 100. Okay. Now, I remember you said in 2011 that at the time you said in 10 to 20 years you could put man or human on Mars. Now we are 2015, so that will actually happen. If your prediction is correct, it will be 2020 or 2030. It's not that far away from now. Are you still optimistic?
I think about 10 years.
In 10 years?
Yeah.
Roughly, by you.
Yeah, it's looking at. Well, I mean, there'll be others, not just me. But, we have a very talented team at the company, so yeah, 5,000 people at SpaceX. So.
Yeah. It's not, it won't be easy when you look reusable rockets because NASA stopped space shuttle. It's very expensive thing, so I'm not an expert on that, but I guess it's not that easy. So why was so confident that you could do this?
I mean, at this point, I feel quite confident at least achieving blue stage reusability because we've been able to land the blue stage twice in the ocean, and we've been able to at least hit the ship twice. And the second time, it took several seconds for the rocket to explode. So we're making progress. I think I'm highly optimistic that in the next 12 months or so that we will be able to land the blue stage safely and reflight. That one is, I think, highly likely.
High.
90% plus.
Okay. What's the probability in 10 years we'll see a person on Mars? What's the probability?
Well, I'd give it 10 years. I'd make that sort of 50% likely. It sort of depends on what happens with the world, and but if one were to extrapolate current trends for SpaceX, I think 2025 is around approximately correct. Yeah.
10 years from now, so that's.
Yeah, approximately. So I think the fact that reusability is important. This is an example of where first principles analysis makes sense, because if you were to look at say by analogy and say, well, let's look at prior efforts to achieve reusability, such as the space shuttle or the Russian Buran program, and say, well, those attempts at reusability did not result in any improvement in the cost of spaceflight. In fact, they increased the cost of spaceflight. So the shuttle shuttle budget was about $4 billion a year, and there were typically 4 flights per year, so obviously the cost was roughly $1 billion a year. And this was much more than an expendable rocket of equivalent payload capability. So then people would look at this and say, well, based on that, it would appear that reusability increases the cost, it does not decrease it. However, so this is not true if you look at it from a first principle standpoint, because if you look at say what is the cost of the propellant used if you use low-cost propellant such as refined jet fuel, and in the case of our rocket, the propellant cost is approximately $300,000 per flight. But the rocket costs $60 million. So that's a pretty huge difference. You've got the cost of propellant essentially approach the cost of propellant. You're factoring in maintenance and other issues. And so if something similar to aircraft occurred with rockets, then you might have the cost of maintenance of both be roughly equivalent to the cost of fuel as it is with airlines, which would mean say $600,000 cost per flight time, which would then be a 2 order of magnitude reduction.
So this is really a good example to show that think in terms of those principles radically different from think using analogy. Right? Using analogy you will not find anything positive, but from the first principle.
Absolutely, and the same can be said of even building a rocket in a reusable contribute. Building a rocket, whether expendable or reusable, to say what should a rocket cost. One can look at what rockets have cost historically and say, well, that's what rockets will cost. Or you could say, what are the material constituents of the rocket? If you were to say, what is the weight of aluminum, titanium, inconel, carbon fiber, and other elements, and if you had them sort of arranged in a pile of raw materials in the room and had a magic wand and could rearrange the elements into the shape that you want, then that would describe the minimum possible cost of any given physical object. And so then the trick is how you get them in shape effectively. And if you do that, you can see that the actual cost of raw materials in a rocket, again, expendable or reusable, is quite small. It's only a few percent of the price. So then the trick is, how do you rearrange those raw materials into the shape you want efficiently?
The lesson is, again, go back to the first principle. Everything goes back to the fundamental assumptions. I know that your dream, your aspiration is to send humans to Mars, but your dream is to build a city on Mars. Is that true?
Well, if you think of it sort of broadly, the history of human civilization will fundamentally bifurcate along two directed or natural. And, a self-sustaining civilization on some planet. Mars is really the only realistic possibility. And so I think we should try to do that. And this is the first time in the 4.5 billion year history of Earth that it's been possible for some life form to extend life as we know it beyond Earth. That window may be open for a long time, or it may be open for a short time. The prudent thing would be to assume that it's open for a short time and take action while we can.
Very good. So that's a really your dream.
Yeah, I mean, I think
Why not
that's
dreams?
in the sort of context of existential threat minimization, I think is something we should aspire to.
From the first principle of physics, you think that's possible?
Yeah, absolutely.
Very good. So now, your name is very closely associated with Tesla Motors, because Tesla is a public company, SpaceX is not, and also Tesla make cars for consumer markets, so it's very natural that people know you through the Tesla cars. Now, I know that there are many car makers making electric cars. Nissan, GM, Chevrolet, Bolt, Ford, Focus. I mention these three because the three CEOs of these companies are on my advisory board. But none of them are here today. I will be there tomorrow. So there are a lot of competition here. Everybody knows that EV or electric cars is the way to go. Now, I know that you are now from Detroit. Your Tesla is located in the Silicon Valley, and it's a very different type of company, different type of philosophy, etc. So, what made you think that you have the advantage over those traditional car manufacturers, or some potential entrants from other Silicon Valley companies? I don't want to name. There are many there. So, tell us about your idea about the Tesla cars.
Well, sure. Well, similar to SpaceX, I thought the chances of success of Tesla in the beginning were extremely low. I mean, the history of car company startups in the United States, or probably elsewhere too, is not a very good one. There's a large graveyard filled with attempted car company startups. And in fact, in the history of the U.S. automotive industry, thus far, only Tesla and Ford have not gone bankrupt.
Only Tesla and Ford.
Yeah, everyone else is like...
You studied the history of that.
Yeah, they're all, yeah.
So the probability of sign at the beginning, the success or the survival of Tesla was even smaller than SpaceX.
Well, I think both comparably tiny.
10%.
Yeah. for SpaceX, the first 3 launches didn't work.
No.
And I only budgeted for a maximum of 3 flights. Unfortunately, we scraped together a 4th flight, and the 4th flight did work. But if that 4th flight hadn't worked, that would have been it. And then for Tesla, many times we came close to bankruptcy, and all the way to the financing round at the end of 2008. We closed the financing round on the last hour of the last day that it was possible, which was Christmas Eve 2008. And if we hadn't closed that, we would have gone bankrupt a few days after Christmas. So I think we really very narrowly survived. And now, today, I think both companies are in a much stronger position. So, Tesla's got the Model S and the Model X coming out, and SpaceX has contracts with a large number of companies. In fact, most of our launch contracts are actually commercial. A lot of people think it's mostly NASA, but it's actually mostly commercial, launching communications and broadcast satellites. So we made it through some quite difficult times. But I think the probability of success was low. So I do think there was some good fortune in our survival.
You are lucky, or is something else there?
I think we're at least partly lucky, yes. Yeah.
Probably.
At least partly lucky, yes.
Okay.
Definitely.
And the Model S and Model X, they're all quite expensive and luxury cars. So people want to have a great and affordable car. So future Model 3, right? Will be. So every moment to decide which company will win the market. That's the wrong way to think.
Many winners. Yeah, the car industry is very big, and it was almost 100 million new cars and trucks built every year. There's 2 billion cars and trucks in the fleet, and the most market share that any one car company has is 10%. So I think there's certainly room for many winners in the electric vehicle space, and it will be. So I think it's really, it's not a one company makes it all or anything like that. I think it's really, it's not a natural, it's not an industry where there's a natural monopoly. This is it's a sort of naturally highly competitive industry, and I think all cars will really, all transport with the exception of rockets will go fully electric. I think this is very obvious.
Everything goes here.
Absolutely.
Everything. Airplane.
Everything except rockets.
Except rockets.
Yeah. Typically so it's not even studying.
There's still room to do electric rockets.
No.
No? No. You are so sure. No.
Yeah. And what you need to react a mass. So unless so once we vacuum, it's like nothing push against. So unless you shoot something out the end, it's not going to work.
Okay. Now let's talk more about cars. Your concept cars is a different idea from others. You consider them as pets somewhere. Maybe wrong. I mean, sort of, you have to take care of that. You have for example, you're doing many things. For example, this thing of it's called OTA, the over the air. You can upgrade software. You don't have to go to the garage. This is a different kind of experience. This is something that
I just think over-the-air updates are kind of normal. That's what people have come to expect in consumer electronics devices. I mean, if you had a phone that didn't do over-the-air updates, it would be pretty strange. So we're really just doing the things that would be considered normal for phones or laptops and applying them to a car. An electric car is basically just a laptop on wheels.
It's a laptop on wheels.
Yeah.
So this is your concept car, electric car.
Yeah. So it's maybe seems unusual for the car industry, but it's quite normal for consumer electronics. And so we're just doing the normal thing, really.
You think this is very natural?
Yeah.
This reminds me of cell phones. The concept cell phone used to be with phone calls. Now everybody has a smartphone, has many functions there, help you locate, and many things, but making phone calls is tiny part of that. So the cars in the future will be a very different concept from the cars today. It's not like a moving vehicle.
Well, I think the way things can go is to full autonomy electric. That's,
Full of autopilot?
Yeah.
Is that called autonomous car or driving?
Yeah.
What's the name for that?
Well, I think the autonomy grows in steps.
Mm-hmm.
We released Autopilot version 1, which is a sort of semi-autonomous capability for the car.
Mm-hmm.
And this will get better rapidly over time. My guess is that within 3 years or less, there'll be cars that the production cars that you could buy that are fully autonomous, pending only regulatory approval.
Okay, there's no technological problem there, it's just a regulatory problem here.
Yes.
You think the day will come, you will think further ahead, that it will be illegal for humans to drive a car. Is that possible?
I don't want it to be illegal. I think that some jurisdictions may decide that it's unsafe for people to drive cars in their future. But this is not something. I mean, I'm in favor of people being able to drive their cars. But it's possible that some jurisdictions may make it illegal to drive a car because it's too dangerous.
Okay, there are some jurisdictions on Earth
They may.
would make illegal for humans to drive a car because it's too dangerous.
They might.
Okay, that's
Statistically speaking, this will be true. Sure.
But now, the regulator face the problem that without a driver, that considered to be too dangerous, right? Right now, so you are really thinking that, opposite way.
Well, yeah, I mean, at the point at which an autonomous system is demonstrably statistically safer than a human driver, the question will be, should you allow this or not? This will be up to various communities to decide whether something that's more dangerous than a person driving, or if it's more dangerous for a person to drive, should this or should it not be illegal? And some will probably make it.
Okay, so this is a legal and regulatory issue, but not a technological issue.
Correct. Technologically, this will be no problem in 3 years.
We have an expert here on electric cars, Professor Ouyang. He is a senior professor from automotive engineering department. So Tsinghua has a department of automotive engineering. So he is an expert on electric cars. So
I would like to mention something happening in China. The EV output volume is approximately 150,000 this year in China. It's the number one in the world.
150,000 cars made in China this year.
Yes.
It's the number one in the world.
Number one.
That's great. That's awesome.
So we also have the high-speed electrified railway, okay, and also large amount of e-bike, 200 meters, something like that. So, what is your value? And the role of China in the global transportation electrification, and also what role was Tesla Motors play in the EV development in China, and what the special plan will have to serve the middle-income Chinese customers.
Sure. Well, I think it's very impressive that China has such a high number of electric vehicles being built. I think that's great. And I was sort of really impressed to read about the CO2 cap and trade plans for China. So I think this is great. China is becoming a world leader, always a world leader in sustainable energy, both on the production and consumption side. So I think that's a really, really cool thing. From a Tesla standpoint, And we're doing our best to help others in the industry. So we've taken our patents and we've made our patents open source or just freely available. So any company can use our patents at no cost. So I think that hopefully that is helpful. They don't even have to tell us that they're using it. So it's, hopefully that is being helpful to some companies in China. And then of course, as we create new cars, then those can be case examples of what's possible with an electric car. And part of the reason, for example, we're trying to achieve very high performance numbers, like very high 0 to 100 kilometer acceleration, is to show that an electric car can be a really fun, high performance car, and it doesn't have to be slow. So we're trying to make electric cars cooler than gasoline cars. I think this is very important. But yeah, I think it's very exciting what's happening in China on the electric vehicle front, and I think what the government is doing to encourage electric vehicles is great. So I think a very promising future.
Yeah, I think the most difficult things is to balance the knowledge and the cost. What will have a special things that are come in this aspect?
Yeah, I think with our third generation car, Model 3, that will be half the price of the Model S. Long term, we also expect to do local production in China, which will help quite a lot because we currently have to pay quite high import duties, which increases the cost of the car to consumers in China. So we are, in the long term, with local production, they wouldn't have import duties, and the car will be a much higher volume, and it's designed to be a global car. So effectively, it would be maybe a third of what the current car costs in China. Yeah.
Only 1/3.
Yeah, it would be sort of 1/2, but then factoring in local production, it would be 1/3.
1/3.
Yeah, something like that.
So that will be truly affordable.
Yeah,
Car.
long range as well.
And a long range. So there's no technological difficulties here. You think you solved that already, or you are still on the way?
Well, we're about 2 years away.
You are 2 years away from
Yeah.
that.
Yeah. Same as you. I do feel confident about the better technology and the EV's future. However, the market share currently is below 1%.
Right now. The worldwide.
Yeah,
1%.
below 1%.
Below 1%.
Below 1%. So, what's your prediction about the future in 5 years, 10 years? And how do you think how long the electric vehicle can replace conventional cars? And what make you believe your conclusion is reasonable?
Sure. So, about 5 years ago, I met with a friend that 20 years from then, so 15 years from now, a majority of all new cars produced would be electric. So 15 years from now, I'm highly confident that more than half of all new cars produced will be electric.
By 2030,
Yeah.
more than 50% of new cars produced are electric.
Yeah, so it will still take a long time to change out the fleet because the new car production capacity is about 100 million and the fleet is 2 billion because the average age of the car before it's scrapped is about 20 years. So even at the point when it's more than 50% of new cars produced are electric, it will still take a long time for the fleet to become electric. But I feel very confident that they can make that prediction.
So you think China will have a even bigger share in comparison to other countries?
I think probably China will have the biggest share.
Because?
Because China is, in terms of industrial, no question, China will have the most.
Yeah, I fully agree with you.
So in order electric cars work, in addition to car itself, you need a battery and electric charging infrastructure. You need a network. You need a huge infrastructure here. Now China, has this reputation that it can try to build infrastructure very quickly and at a massive scale. we think that this is also the area that China could actually leapfrog to other advanced countries, because first, this infrastructure requires a lot of investment, but investment itself, generally resources. So what do you think of China, this infrastructure investment in China and in the US or Europe or other developed countries?
Yeah, my guess is China will be in the lead in this area. Certainly, I mean, it's possible that some of the smaller countries may be ahead, but of any large country, it's very likely that China, there's, small, like Norway is really, okay. So Norway's great, I love Norway, they're awesome leaders in Norway's the leader in electrification on a percentage basis.
On percentage basis?
Yeah.
Among the large countries?
Among large countries, China for sure, yeah.
Sure.
Yeah.
Very good. So that's also good for growth and economies. So we are looking for places that make useful investment, not wasteful investment. So this is the area. And I think infrastructure, all these.
I also think it's actually going to be quite widespread. I mean, it's rare that some place doesn't have electricity.
Right.
And most electric car charging will occur at home, and then some at the office, and then only for long distance. So I think a lot of times people think, well, you have to have charging stations all over the place, like you have gasoline stations. But this is not true. But you only need to really have charging at home, at the office, and then for long distance purposes. But with the exception of certain municipalities where if you have street parking, you need some way to charge a car for street parking. But this is on a total population basis, this is a small percentage of the population. But certainly in places like Beijing or Shanghai, you need to have some sort of, that's where government help is important, because people need some place to charge their car. Essentially, wherever their car spends the night or the day, that's where the charging needs to be. But it doesn't need to be at supermarkets and convenience stores and that kind of thing. That's not necessary. People will end up charging their car where they charge their phone.
I think you're quite right in terms of rational analysis, in terms of physics, but there's a psychological problem here, right? People's anxiety, people's thoughts, they need a lot of charging stations, otherwise they're afraid. This is the exact anxiety, or the psychological problem.
Yeah, I think it's really just a psychological problem. Yeah, the reality is, if you have an electric car, you have no problem. Yeah, exactly.
It's a clean energy, it's different. Now, actually the Chinese have been very enthusiastic in this area. As over enthusiastic to such extent, we have in the last couple of years, several big companies actually ran into problems. You probably know that some famous Chinese photovoltaic generation, energy generation companies and whatever. So, in your case, for the city, what's your secret of success? Volume, these steps, or the tracks? Was the business model or technology or what?
Well, it should be said that China is the largest producer of photovoltaics today. So although there have been some prominent bankruptcies, nonetheless, China is the leading producer of photovoltaics, and I think that's a pretty great thing.
With a lot of government subsidies and yes, a lot of, I know, huge production, but economic or financial impact.
Yeah, I mean, the subsidy question is an interesting one because, I mean, as a general rule, and since you obviously, as an economist, you probably agree that generally government intervention in the economy is usually not the best idea. But I think the reason for that is that it is you don't want to increase the error in the economy. So prices are just information, and so if a government action causes the information error to increase, that will generally result in negative. At a meta level, the government should really be thinking is how do they reduce the information error in the prices in the economy, reduce the error. However, and I think anything that places so to the degree that one believes that the CO2 capacity of the oceans and atmosphere is a public good that can be consumed at zero cost. Anything that causes that cost to be above zero is reducing the pricing error in the economy. Now, generally, taxing CO2 is not a popular thing. So therefore, what the government tries to do is to subsidize low-carbon activity. So, like photovoltaics and electric vehicles and that kind of thing. So this is not as good as pricing CO2, of course. Pricing CO2 would be the best thing, but that's really what's occurring. Is that it is to try to even the subsidies on clean energy or on electric vehicles. It's an attempt to correct the pricing error of CO2 producing entities. So another way to think of it is there's a huge subsidy on anything that's CO2 producing that is not being paid.
Now I can see you did study Econ 101. Basically, you make this argument.
I'm a big fan of Econ 101.
You're fond of Econ 101.
Yeah, that's great.
It's useful as Physics 101. You think equally useful?
Physics 101, there's a great service. Fundamentals of economics, everyone should understand that.
I'm teaching Econ 101. Good, very good. So now back to the question that what was simply that make this solar city company very successful, avoiding the maybe pitfalls of other similar companies. Business model? Or?
Sure. In the case of solar city, if you look at the cost, the fully installed cost of solar power, it became apparent that the non-panel portion of the cost was really dominating. So essentially the cost of designing a solar installation for a rooftop and getting the solar panels there and installing it and doing the wiring, connecting the inverter and the permitting and the maintenance and all these things which were largely unglamorous and not sort of hard to say they're technologies in and of themselves, but they are actually technologies, but essentially the balance of system costs were dominating the fully installed cost of solar power. And so that was really where entrepreneurial energy was needed. And so I was able to convince two of my cousins who are very capable entrepreneurs to start a company in solar to address this essentially the non-cell portion of the classical installed solar.
So you identified the problem, asked your two cousins to do it. What were their background? They were engineers or they were what?
One's engineering and one's sort of more on the kind of sales and overall leadership. Yeah, they're both very, very good guys, and they'd actually created a company that I had nothing to do with called Evergreen that was developed to do large-scale management of computers and computing devices. So if you're somebody like, say, FedEx, and you've got 60,000 computers around the world, how do you manage all those computers? So they created software for managing huge numbers of computing devices from a central location, which actually works out well for managing then millions of solar rooftops from a central location. And so they're able to do that. And in the case of that, I thought there was a higher probability of success than Solar City or than Tesla or SpaceX. I thought that was a good chance of success in that situation. And they've done an amazing job. I basically just, for Solar City, I just show up at the board meetings and get good news. That's my contribution.
You are chairman of the board.
Yeah.
And you are a large shareholder. Yeah. So you give advice, basically, your cousins doing the work.
Yeah, just some advice here and there. But it's really, the credit is all done.
It's a publicly listed company.
It is.
So, this is, we have also experts from the EE, the electric engineering. Tsinghua has a very, very good EE department. Our founding dean, Zhu Rongji, we are going to meet tomorrow. He graduated from this department. They do a lot of energy-related issues, so I would invite him to ask questions.
And I got to know that Solar City will build two solar plants for every samples is okay. And I know, and it's a good news for you, I think. In China, we plan to install about 600 gigawatts in the next 2 years or so. So, what I want to know is, could you give us your view about the future energy world? And what do you want to do most in your energy energy?
Sure. Well, I think what I hope Solar City does is accelerate the advent of solar power, and this becomes something really just an economic question. The lower the sort of the expected cost of energy from solar, the faster it will be adopted. I think there's good progress being made every year. Although it is hampered by the fact that CO2 producing power is effectively not paying its rent. They're not paying for the CO2 capacity of the oceans and atmosphere. But despite that impediment, I think solar power is making great progress, and it will continue to grow every year. Albeit not as fast as it should grow, but it will continue to grow every year. Yeah, so I'm not sure if I'm answering your question, but yeah.
I just want to know what's your view about the energy system or infrastructure or in the world?
The main law, what percentage do I think will be?
Yes.
Yeah. I think in the long term, a majority, probably a super majority of all energy production will be photovoltaics. Essentially, we have a giant fusion reactor in the sky from the sun, and it's spreading energy. So I think people don't quite realize just how much energy reaches the Earth from the sun. It's a big thing. It's 1 gigawatt per square kilometer. That's the solar incidence on Earth. So, in fact, if you took most nuclear plants and you took the clear area around a nuclear plant, which is usually quite significant, and you just put solar panels on that clear area, you would usually generate more energy from the solar panels than would from the nuclear plant.
And I just have another question. I think you feel the SpaceX and Tesla are very different. Is there anything common among these things?
Your three, PayPal,
Yeah,
Tesla,
and
SpaceX. Anything common?
Yeah, anything common.
Other than all done by it, right? Other than this factor, what things in common?
I think there are commonalities between any sort of new technology development. I think new technology is developed in a similar way. So, I mean, PayPal is really a software company, a software technology company, and obviously Tesla is a sort of car and energy storage technology company. SpaceX is a rocket technology company. And the way in which one, say, organizes engineers to achieve a particular outcome in technology development is the same, I think, in any arena.
Tesla, because I think you raised the issue of some common basis. You mentioned earlier that you actually faced SpaceX and Tesla face very, very difficult time, almost died in 2008 before Christmas. NASA gave you a call, and then the Tesla got the last moment got finance. All happened before the Christmas Eve, at the Christmas Eve, right? So this is, for anybody, that's a huge pressure, a real danger. So how did you survive this? And did you have a conviction, or did you have lucky, or did you use your DNA to fight the last minute? So what's your experience during those very times of big actions? That was really help them when they face difficulties and come
very good opportunities.
Really, just
Well, I think it's a very difficult thing to create a company, honestly. I'm not sure I would recommend it. I mean, generally the way that things go with creating a company is that at the beginning, they seem quite optimistic. You know, there's sort of this initial period of optimism and possibility. And that might last for 6 months, maybe as much as a year. And then there's usually several years of extreme pain, followed by failure. That's normal.
that's normal.
That's normal.
That's normal. So
Yes.
then, how to deal with that? How to do that?
Yeah, I would say, I think you should do it if you think that there's a really compelling reason to do it. Yeah.
What's the compelling reason?
I think it varies by individual. You know, in my case, it was just I think I would take half the money that I made from PayPal and then if I lost half the money, that would be fine because I would still have
You still have the
I
other
still
half.
have the other half. It's no problem. But this is not how it works, you know. And I mean,
You put more than half. Yeah.
I think this is true for a lot of people, but for me, it was like the company becomes like a child.
Okay. Company is a child.
Yeah, and so then, how do you say that your child should not have food?
You should have food.
Right.
So, okay. Take your company as a child. Then, that's good analogy.
Yeah.
It's not frustration. It's a good analogy. It's a good analogy.
Right.
It's a takeaway, right, from this. So this gives you a strong will to kids. Plus, you feel you're not.
I think so. Yeah. It was a close call.
It's a close call.
Yeah.
It's a close call. Yes, it is. Now, I know that you read a lot. You just mentioned that you self-taught, space technology, energy, many computer programming and other things. Now, I'd like to know that what do you read other than technology books? What do you like most in science fiction, philosophy, religion, history, or even biology? Can you share with us that type of books?
I think there's a lot to be learned from the lessons of history.
Some examples of
Well, there's a lot of examples.
yes.
Again, I think just in general, to read about interesting people through history and the difficulties they faced and how they overcame them. This is, I think, really compelling. I think just reading in general is great. I mean, reading, amazing people like Shakespeare.
Shakespeare.
It's one of my favorites.
Your favorite one of your favorite Shakespeare.
How can you not be? There's just a lot of amazing things. A big fan of Ben Franklin.
Very practical, a inventor,
Yeah.
among other things.
One of the other things, you did the right thing at the right time.
You did the right thing at the right time. You're also thinking the right thing at the right time.
Yes,
That's another matter.
yeah, I believe it's right. I mean, certainly, all Einstein, Darwin. Darwin's a great writer. Darwin's a great writer.
Great writer.
Great writer, yeah.
So reading is evolutionary theory.
Yeah, seems like a little bit.
So, you like science fiction too, right?
Yeah, I think the thing about science fiction is that it's free from the normal constraints.
Yes.
Whereas, books that are that are sort of set in the known context or the normal context, they can be interesting to read, but they're within a confined framework, a limited set of degrees of freedom are limited. Whereas in science fiction, there are many more degrees of freedom. Recently I was reading books by Ian Banks, the Culture series. That's amazing. That's a really super I'm a big fan of Asimov and Heinlein.
Okay.
obviously developing because a lot of amazing books in science fiction, a lot of really interesting ideas.
You got inspiration from it, or got some ideas from it? Because it's free of many constraints that we use.
Right, exactly. I must have, I think I certainly got inspired by a lot of science fiction books. They sort of really have this incredible imagination. I mean, it's sort of, if you can imagine going out and exploring the stars, that would be an amazing thing. So I think we want to be on a path to making sure that those books are not always fiction. Like one day we want them to be true.
But give you inspiration.
Right.
Have you heard the science fiction book of China, the most famous one called Free Body? Have you heard that? It was translated into English. I recently got some huge prize. So this is the best known China's science fiction thing called Free Body. Okay.
I'll get it off.
We're going to talk about that. And do you think you are more engineer or more engineer?
Well, I suppose probably, if those are two choices, I'd say probably more engineer, but I just like to, I just like to try to be useful. I try to be a usefulness.
You try to be useful. You try to be useful.
Yeah, exactly. And sometimes that usefulness means that one has to do something entrepreneurial. Sometimes it's an engineering thing. It's just usefulness.
You already answered my next question. My question is, what kind of person you want to be? Basically, you are saying you want to be useful. So, what kind of person you want other people to think you are? Same thing. People think you are useful.
Yes.
The man is engineer, the man is entrepreneur, and that's useful.
Yeah, exactly.
So this is the legacy you want to leave?
I think that's a good general optimization. I think that's generally, if someone did something like that was useful, I would productive, it help the community, that's a good outcome.
So far, you are in the early 40s, so you are pretty satisfied with what you have done so far?
I mean, it seems to, so far so good.
So far, so good. And you want to go to Mars?
Yeah, whether I go to Mars or not is, I'd like to go to Mars, but that's completely out of there. And hopefully, the technologies that SpaceX develops can enable.
You are very, very successful. But at this time could be reversed. Could you design and choose your career, your life, your education, and next most perfect? Well, what's your advice to the students of Tsinghua? There are a lot of people who are taking you as an example. What's your advice?
Sure. Well, I think it's a good idea to study a broad range of subjects. A lot of innovation comes through cross-fertilization from one area to another. Because increasingly, as our knowledge base grows, we become quite sort of siloed in our knowledge. So you'll have someone who's very specialized in one area or another area, and then if you can combine these specialties and create something that's greater than the sum of the parts, there's a lot of opportunity for innovation by doing that. So that's why I encourage people to study a broad range of subjects and to study, if somebody's in engineering, to study economics, to study literature, and to study many different fields. I'd encourage someone to do like the 101 of almost everything. Anything that they find intrinsically interesting. and to think how they might combine things from one discipline to another. I think this is a great way to come up with new ideas.
This is what we have been doing here at the School of Economics and Management, or general education. And also at the university, also Tsinghua is also moving, put more emphasis on general education rather than the specialization of this type of thing. So we think that's something that's very important.
Yeah, I think having a good general knowledge is very important. And then even once specialization occurs, if somebody specializes in, say, 2 areas where you can achieve a combination of
The two.
yeah, that's where I think there's a great opportunity for that.
Yeah. So in addition to this general knowledge, but also we know that this year in particular that the Chinese very enthusiastic about entrepreneurship, startups, and many Tsinghua students here want to build China's Tesla, SolarCity, PayPal, etc. So what advice you can give to these students? Is that a good thing to start a company in college or during a graduate studies? Or what are the important characteristics for being entrepreneurial, even without starting up your own company? So what are the general advice you can give to these the younger generation?
Well, I think if you identify something that some need in society or some want, and then that's really it. Either way, is if you can see that this is something that you would really want, or your friends would really wanted, then you can sort of find like-minded people, group them together, and then try to solve that one for need. That's really it. And the best time to do it is when you're in college or just outside, just finishing college, because your obligations are low. You don't have a family to support, or times when your obligations are low. This is when you should take the most amount of risk.
So it's a personal decision because we know there are famous entrepreneurs. Some of them drop out of college after 1 semester. You know who I'm talking about. There are some who drop out after 2 years. And you drop out of the PhD program in 3 days, but you finish college with double degree.
I did, although I didn't have an external reason for that, which is that if I didn't, I wouldn't stay in university, otherwise they would kick me out.
Oh, there is I think reason for that. So then, you got a good card.
Yeah. And I think also the PhD program, the value that I saw there was that Stanford had all these great labs that I could just use for free, and that would be, for developing electric car technology, that would be very helpful.
You did use Stanford lab?
I was going to.
You're going to?
Yeah.
That's a good idea, actually.
Yeah.
Stay on campus to use for free labs.
Yeah, absolutely.
That's a very, very great thing.
Universities have all these resources.
They have yes, indeed, the university has a lot of resources, underutilized. Interesting, very interesting. Now, we have very limited time, but now I still want students to ask some questions. So now the floor is open to students. Again, we'll give priority to students, so please identify yourself first, which school you're from, and make your question very short and concise. Only one question, not 2 or 3 questions. Okay? Now we have here.
Oh, thank you. Thank you, sir. Here's my question. Can I put something with you? Probably not a question. But I read about a lot of blogs written by Tim Urban, talk about a lot. And there's one article I read about, it's about the AI. Some days later we'll reach the AI, probably by 2060. And you want to send people to Mars because you want to have a backup of human beings. So when the AI reaches a God point, it doesn't matter whether we have a backup or not, because either we're going to go extinct or we're going to be eternal. So what's the point for you to move people to Mars when you know that we are going to reach a dark point? That's my question. Thank you.
Well, I think that certainly would be protected against a natural disaster such as an asteroid collision or a supervolcano or some sort of shifting of internal shifting of the magnetic field. There's a bunch of potential life extinction things that can occur, as has occurred many times in the fossil record. So just for that alone, I think it's worthwhile to become multi-planetary. And then there's also the self-extinguishment possibility. I certainly hope there isn't a World War III, but there could be one. And if there is a World War III in the future, it may be quite devastating, given the power of technology today. And so then it would be good for us to be a multi-planet civilization at that point. And then, but I think the defensive reasons for becoming multi-planetary are not as compelling to me as the exciting, inspiring reasons. I mean, I just think that if we were to create a city on Mars, it would be a very exciting adventure. But I think the most exciting adventure I can possibly imagine. It would be very inspiring. I think even for people that don't go, it would be very inspiring. Just as the Apollo program was inspiring for the whole world, even though only a handful of people went. In a sense, we all went to the moon. And it's important that there be things that are inspiring and exciting. I mean, if life is just about solving one miserable problem after another, why is that at all?
Why is it at all? Well, so let's have a question this side. We will have this. That have one.
Thank you. Good evening, Mr. Musk. Firstly, it's so exciting for us to meet you here in our school. You are really the hero of the Chinese boys who are interested in business and technology just like me. And also I see the dream lover of the girls, I guess.
So what's your question?
Sorry, I'm a member of the accelerator. I graduated from Tsinghua ICM, and there are many people here. We are all running our own companies. My question is, as we know, the innovation from 0 to 1 is becoming more and more important for our economy. As the genius in this part, could you give us, the young entrepreneurs, some suggestions how we can to break up the traditional mindset and find a new continent in business? Thank you.
So you mean sort of advice on sort of how to make your company succeed, and is that really sort of what's good general entrepreneurial advice?
What's your question, please?
Give us some suggestion in innovation for the startup companies.
Okay, sure. Well, I think I touched on a few of those areas already, which would be, it's good to cross-fertilize different domains. So if you look at, say, what's being done in one domain and see what that is perhaps transferable to another domain, and if you combine them, that can be quite helpful. So like, for example, with rockets and cars, the auto industry is very good at producing large, complex mechanical objects at low cost. It's remarkable how little a car costs given its complexity. And so applying those manufacturing techniques to rocketry is very helpful. And going the other direction, the rockets are very good, the rocket industry has become extremely good at mass optimization, making things very, very light. Because if you don't make them light, you can't reach orbit. So then taking those advanced design techniques for making things very light to what seems to be the most fundamental truths in a particular industry, and then reasoning very carefully up from there and to reach conclusions. And then I think it's always good to solicit as much negative feedback as possible, and particularly from friends. Like your friends usually, if there's something that's not quite right with your product or company, your friends probably know, but they're not telling you. So you have to coax it out of them. And for people that care about you, they will tell you if you really want to know, and if they feel like you want to verify the answer. It doesn't mean they're always right, but you should try to get as much critical feedback as possible. One should always take the approach that whatever you're doing is some degree wrong, and you want to minimize the degree to which it is wrong.
So he is from it's called Accelerator. Our school created two entrepreneurship platforms. One is called X Lab, another is called Accelerator. So we like letter X. I know you like letter X very much. You started from X.com, and you have a space X, you have a Model X, so you are even a trustee of the X Prize Foundation.
The triple X situation.
Well, I'm trying to find a reason why you also like the letter X. Is triple X just for that? No. So what's the reason why you like the letter X?
I guess it's underappreciated as a letter.
It's underappreciated that students, X is always in math equations.
That's right, that's true. It's also X, exactly, X, it's always X equals, something.
Wow.
It's, yeah.
Yes. So it's underappreciated that.
And X is on horizontal axis, yeah.
X is also on the horizontal.
Yeah. I don't like it.
You like it. I have a question from this side. Yes, please. Yes, please. Yes.
Is any
Can you identify yourself first?
some possibility in the future your company will pay more attention to the and freshmen and pay more attention to the biology, maybe the truth of the life, maybe present place we are living. The masses in the future, maybe the Earth nowadays. Really, your company will pay more attention to Earth.
Sure. Well, I think Tesla and Solar City
Solar City?
that's
all on Earth.
Yeah, it's intended to help solve or accelerate progress towards sustainable energy. I think hopefully they will accelerate the advent of sustainable energy. So I think sustainable energy is the single biggest problem that we have to solve this century. Sooner the better.
A question in the back? Anyone in the back? Yes. In the back. Yes, in the back.
I'm Daniel Cowell from the Tsinghua MBA program. So I last saw you speak 3 years ago in my native London, and back then Tesla, SpaceX, PayPal had already been created. Since then you've given the world Hyperloop. What I want to know is when you think you'll first see that implemented, and what are you working on that's going to stun the world in the next 3 years? What's the next big thing?
Hyperloop.
When I see you in 3 years' time, what's it going to be?
Sure. Hyperloop, I just basically wrote the paper and published it and just made it freely available because I'm pretty strung out between SpaceX and Tesla, so it was sort of impossible for me to do something in addition to that. But there are a couple of companies that are attempting to commercialize the Hyperloop idea, and I'm hopeful that one or more of them will be successful. And then SpaceX is sponsoring a student competition for Hyperloop to see who can design the best pod. So we're creating a little 1.5 kilometer long test track near our headquarters in LA. And then we're sponsoring an annual competition for pod technology. So I think that should be quite fun. In terms of future things, I think that there's a lot of potential out there for companies in genetics and possibly at the human brain, or the sort of brain-machine interface. I think there's things that were being considered science fiction in the past there's a lot of potential there. I think, as mentioned, like the electrification of all forms of transport except for rockets, so bringing electric jet, electric ships, and these are opportunities. I'm actually a big fan of tunnels. That's sort of also something that's underappreciated. I think we really need to have transport go 3D, and you can either go 3D up or 3D down. If you go 3D up with flying cars, you've got a lot of challenges with noise and potentially things falling on people's heads. And with tunnels, and you also have weather constraints with any aircraft. But with tunnels, you can go just as 3D with tunnels, and you don't have any weather constraints, or no noise. And so I really think there's a big opportunity with tunnels.
The Hyperloop is the idea that you propose that from LA to San Francisco, 600 kilometers or 400 miles in 35 minutes. So I know you're living in LA, but you very often travel to San Francisco Bay Area for Tesla business. So you think that in how many years we'll see this such a marvelous thing? In 35 minutes, it's half the distance from Beijing to Shanghai. 600 kilometers in 35 minutes. Is that technologically, financially, all feasible? You don't have time to do it, but you can ask someone else to do it.
Yeah, no, I think it's definitely feasible. And the paper that I published, has all the math behind it, and multiple outside entities have gone through and confirmed that it's correct. So I think it was initially there was some skepticism, but then so far everybody's said that it is certainly doable. I think it is definitely doable. There's a question of maybe the economics, but I think the economics would be lower cost than high-speed rail, because the cost of the tube per mile would be significantly less. It's basically just a tube.
What's the probability we're going to see this in 10 years or 20 years?
I think there's a high probability of us seeing the Hyperloop implemented on at least some route in the next 5 to 10 years, quite high.
In the next 5 to 10 years?
Yeah. It's mostly about getting the right of way and the approvals as opposed to the fundamental technology. It'll be pretty straightforward.
Straightforward?
Yeah, very straightforward.
Economically, financially? Not good.
I think actually economics are pretty obvious too. Just a tube.
Just a tube?
Just a tube. And a pod with an air compressor on the front and air bearings on the air bearing skis. It's very straightforward.
Very straightforward.
Yeah.
You just don't have time to do it.
No.
You hire other people to do that?
Yeah, absolutely. And I think we'll be quite excited.
Okay, thank you. Thank you, Industry. So actually, I came here tonight by taking one of your first batch of Tesla in China. Actually, one of the 8. So actually, we have a similar business model like the solar city in China, but not by the house, the roof of the house, but by the small factories. Because we have already 100,000 customers who are corporation, so they have the big, many roofs. But in China, we don't have so many houses. So if I have the chance to contact one of your colleagues, so maybe we can discuss a potential opportunity to cooperate, to promote your ideas in China. Okay, thank you.
Is that common or is that
The question is that do you have any plan to promote your solar city model in China?
Well, in the case of Solar City, I pretty much leave it up to those guys to decide what they want to do on an international basis. I certainly encourage them to expand internationally. but they've had their hands full just operating in the U.S. and now recently they've expanded to Mexico. And maybe in a year or two they'll be able to expand to China and other places, and maybe find partners to work with.
Are you a student? Okay, I'll give last chance for female students.
Elon, we really like you. And my question
Okay.
Okay, you're just a superhero, just like Monkey King in the Journey to the West in my heart. My question is, my question is, like SpaceX is just such a wild dream. They kind of for human welfare in the long term. But like the modern financial system might chase the short-term reward, or they will like put a lot of their opinions on entrepreneurs. So how will you deal with the like a wild great dream that might not bring short-term rewards with like the modern financial system? Because one last sentence. Because like Nikola Tesla. I just know him because of the car, but when he was leaving, like the JP Morgan decided to stop the financing to Nikola Tesla to finish his great plan, and that was such a pity for human being. So how do you think about like finance and entrepreneurship?
Nikola Tesla. JP Morgan stopped finance. Okay. So short term, long term.
Yes, but you become rich first, and then you can bear the risk, and of course you can finance yourself. But how about for other entrepreneurs like with
Okay, good. So
yeah, I mean, I think certainly I think something like cars or rockets are kind of like I call it sort of phase 2 entrepreneurship. Because as you point out, there's a significant capital requirement for something like rockets or cars. So it's probably not the best place to start out. If somebody's starting out as an entrepreneur and doesn't have a lot of capital, and the only capital you have is what's in your head, right? And so that's why doing something in, say, software is a great initial thing to do, because software you don't have to build anything, you don't have capital equipment or factories or anything. Yeah, so it's the best way to start out, I think, as an entrepreneur. And then once you acquire some capital, then doing things that are capital intensive is an option. But it's usually quite a difficult thing to start out with.
So good advice. Phase 1, phase 2.
Yeah.
Do software first to make some money, and then do the phase 2 to realize your dream. Real dream. Okay. So that's a very, very good advice. 2 phases. So we have to stop. We can go on forever, but we have to stop. Thank you so much for sharing with us stories and inspiring advice for our students. Really appreciate it.
Thanks for a great question. So thanks for having me. It's a pleasure being here.
Thank you so much.